All right, here on 22, we're given secant of x is 4 and sine of x is greater than 0. We want to find tangent and sine of x. Okay, so just like in the previous problem, you've got a couple of strategies for doing this. We're going to use our identities. Now, secant is 4. Our trig functions are all ratios of side lengths. So if we think of this as a fraction, we can understand it to be over 1. Now, secant's the reciprocal of cosine. So if we know secant, then you also know cosine. So cosine would be 1 over 4. Okay, now them telling us that sine of x is greater than 0 is them just telling us that it's positive. And we can see that cosine is also positive. So where sine and cosine are both positive means we must be in quadrant 1. Now we think of a identity that puts the known, secant or cosine or both, and the unknown, tangent or sine, together. Okay, so the first one I'm going to look for is tangent. So secant and tangent are together in one of your Pythagorean identities. 1 plus tangent squared of x equals secant squared of x. And again, you can look at your formula chart to see all of your identities. So we're going to replace secant of x with 4. Now we're not replacing secant squared of x, just the secant of x. So the squared still remains. So that becomes a 16. And then we're solving. So we have to subtract the 1 to the other side. And then we have to get rid of the square by taking the square root. And remember, when you take the square root in the process of solving, you have to remember to put plus or minus in front. And when you take the square root of a fraction, or excuse me, of 15, if it's not a perfect square, you can try to simplify using your factor tree. But the only factors of 15 is going to be 15 and 1 or 5 and 3. So there's nothing that we're going to be able to pull out. So we'll leave it as square root of 15. So that would be your solution for tangent of x. Now the second part of the question is to find sine of x. So then you ask yourself, okay, is there a identity that puts secant and sine together? There's not one that I can think of, but there is one that puts tangent and sine with cosine. And like I said, if you know secant, then you know cosine. So I'm going to use the quotient identity. Tangent of x is sine of x over cosine of x. And I'm going to substitute in cosine is 1/4 and tangent is square root of 15. So we're going to do square root of 15 is sine of x over, and then that was 1/4. Now I need to take a step back. I just realized something. We determined at the very beginning that this is in quadrant 1 based on the fact that sine and cosine are both positive. So down here in our solution for tangent, if we're in quadrant 1, tangent cannot be negative. It's got to be positive. So we're not going to leave the plus or minus. We're going to determine that it's positive based on what quadrant you're in. So it is just positive square root of 15. All right, so here to get rid of the divided by 1/4, you would multiply that over to the other side. So times 1/4. Okay, so we got rid of it over here. So that becomes root 15 over 4 is sine of x. And there's no simplifying that we can do there. So that's going to be your solution.